The reason is that we just omitted this second argument, that is omitted the argument of n digits. So if we omitted this argument, and by default, it will return the integer. So it's claimed by this rule, the return value is an integer if n digits is omitted or not. Okay? However, if we say this, like, it's still 5, right? However, if we set the second argument as 1, so what would be the return value? Great, 5.3, right? And if we set it as 2, what will happen? So, right, it remains the same, right? Since if we have the 2 as the second argument, then the return value should be 2 decimal places. Okay. And the more tricky part is that what would happen if the second argument is minus number? So what would be the return value of this? Great, exactly. It will be 10. So this just return the closest multiply of 10. Okay. So similarly, any questions? So similarly, if we have like 56 here, and if we have -1, so what should be this return value? It will be 60, right? So we can do as many examples we want. So we can also see this, -2. So what should be the return value of this? It will be 100, right? Okay, so this is the idea of the return value. So the tricky part is that, so this n digits may be negative, and if it's negative, then we find the closest multiple of 10 or 100 or something like this. And if it is none or omitted, then it will just return an integer. And if it's decimal, and if it's like a 1 or 2, and it will keep like one decimal place or 2 decimal places. Okay, so this is for the round function. Okay, so much for this round function. And next, I will introduce the first modular covered in this lecture, covered in this class. That is the math modular. Okay, math modular. So this math modular is a standard module in Python, and it helps us access to more functions and numbers. And modulars are simply files with .py extension containing Python code that can be imported inside another Python. So if you check out your Python library, and you will find a file named math.py. So that's the math modular. So how can we make use of such modular? So generally speaking, we can import math. And after that, we can use the functions in the math modular. For example, we can use the functions math.py to get the value of pi, right? However, an awkward thing here is that it returns too many decimal digits. So how should we take care of this issue? We can use our round function, right? We can use round math.py. Sorry, math.py. And if we want one decimal place of pi, and we can type 1 here, and in that way we get 3.1, right? And the same for the e value. Math.e, and we get the e value. And the same here. If we want 2 decimal places of this e value, and we can type 2 here, right? Okay, so this is about this math modular. And two other important functions in mass modular is mass dot cell and mass dot floor. So how does those two functions work? So as always, we use a help function to learn how those functions work. Mass dot cell and mass. Okay. Okay, we can use this help function to know how those two function works. So it says that for mass dot cell, it will return the cell length of x is an integer, and this is the smallest integer that is larger than x. That is the first argument. And for the mass dot floor, it will return the floor of x is an integer, and this is the largest integer that lower than x. So we can see several examples here. So we can type mass dot cell like 4.6, and we got 5, right? If we have the same value, and but 4, and we get 4 here, right? Since 4 is the largest integer that lower than 4.6, and 5 is the smallest integer that larger than this 4.6, right? So that's the idea of those two functions, mass dot cell and mass dot floor. Okay, so the next modular I want to introduce is that random modular. Actually, there are lots of modular in Python, and you can also explore the other modulars yourself. It's very interesting, actually. So this random modular can help generate random numbers. And a very, very important function in this modular is random.randint. Okay, this one. So how does this work? And we can always use the help function to learn how does one function works. Okay. Oops, happens. Oh, did you forget to import random? It turns out I did forget to import random, right? So we import random here. And then we do it again. Help random dot randint, okay? And it says that this function generally return random integer in range a to b, including both end points. Okay? So let's try several examples. If we have random dot from 1 to 100, right? And if we do it again, and we get another number, and if we do it again, we get another number, and we can do this. Okay, so it basically returns some random integer in a range. However, a problem here is that it only returns integer. So if we want some random decimal digits, how should we do? So for that purpose, we can use another function named random.uniform. Okay, so this uniform just get a random number in the range a to b or this a to b depending on rounding. Okay, so let's try this. So the same range here, and we can type uniform. Use uniform to replace this one. Uniform. Okay. Right? We got some decimal numbers. Okay, and we can do it for several times, and we'll get different numbers. Okay. However, an awkward thing here is that sometimes we don't want that long decimal numbers. We only want one decimal place. or 2 decimal places. So what should we do? So we can use our round function again, right? So we can do like this, round. And in the argument of this round function, we just copy this and type it here. And if we want 2 decimal places, and we type 2, right? Right? Oh, this should be some 9. So these 2 generally what happens here? Let me check this. Oh, this should work. Maybe this is just 99.70, so it just leave the last 0 here. So in that way, we can use this round function and this random function to get the 2 decimal places. Okay, so we can use this to get any random decimal we want. So that's the combination of functions of round function and this random uniform function. So this is the random modular. Okay. So we have introduced the math modular, the random modular, and several arithmetic operators. Okay. So now we will introduce some object types. So now let's start with our slides. So we can have a quick review of what we have already discussed. We have already introduced the numbers and some arithmetic operators, right? And we have also discussed the order of precedence. And first of all, terms inside parentheses, and the second one is exponentiation, and third, multiplication, division, and modulars. And the first one is addition and subtraction. Okay. And we have also introduced the 2 other operators, the integer division and modulars. And we can use this to convert inches to feet and inches. And we have also introduced the ABS function, right? The round function, and a very interesting thing, right? So integers may be negative, so that is the second argument may be negative. And the math modular, and is the cell function and the floor function in the math modular. And additionally, the random modular, right? And we discussed this random function and this random uniform function. All right. So now let's talk about this object types. So as we have discussed before, there are 2 types of numbers: the integer and the float. And on top of that, we also have the string types, list and tuple. So how can we categorize the type of an object? We can use this type function, right? So let's try in this IDLE. Okay, so the type function. If we want to know the type of a variable, so what should we do? We should use this type function. For example, we have this, and then the return value is that. So this argument, the type of this argument is int, that is the integer. And if we have this 3.0 and the class type of this 3.0, which is a decimal number, and the class should be float. Okay. And if we have somebody's name, like my name, and this should be string, right? String. And interesting things here is that if we have this number in quotation mark, so guess what? So the type of this is still strings, since this is in a quotation mark. So everything in quotation mark, we call it a string in Python. Okay? And we can also check a rule we have discussed. So for this, so what should be the answer? The answer should be float, right? Also, 6 divided by 2 is 3. However, as we have just introduced, if we have this division operations, then the result will be a float. As a result, if we ask Python, so what is the type of 6 over 2, and the Python will return with a float. Is that clear? Okay, and another rule is that the result of any other arithmetic operation is a float as long as at least one of the numbers is float. So what does this mean? So we can see here. 6 plus 2.0. So we know the answer is 8, right? However, since one of the number is a decimal point, is a decimal number. The decimal number is a float, so the result will be a float. See? So we have the class for this is a float. And we can also try similar thing if we have 6 plus 2, and the answer should be an integer. Since both of them are integer, and integer plus integer, and we get an integer. However, if we have an integer plus a float, and we get a float. So that's the other rule in Python. So if we get this, so we see this is a float. If we want to transfer this float into an integer, so what should we do? And we can use the int function. The int function. So we can try this. Int 6 plus 2.0, and we get 8, right? And moreover, the int function will leave integers unchanged and converts floating point numbers to integer by discounting their decimal point. For example, if we have 6.9, so for this we get 6. Since it's just counts the integer, but leave out this decimal part. Okay, so what's the difference? So let me ask you guys. So what is the difference between this int function and math.cell we just discussed? So what's the difference? Let's check it out. Int 6.9, and we only keep the integer part, right? Which is 6. Okay. And if we have this it should be math.floor. If we have this math.floor 6.9, what do we get? We still get 6. So what's the difference between those two parts, or those two functions? So what's the difference? Could you come up with any examples that distinguish those two functions? So actually, those two functions are exactly equivalent to each other for the positive numbers. However, for the negative numbers, those two functions are not the same. So to check this out, let us do with another couple of examples. Minus 6.9, and we get minus 6, right? Since it only keeps the integer part, which is minus 6. However, if we use math.floor, what we'll get? We'll get minus 7, which is not the same as minus 6, right? So that's the difference between this int and math.floor. Sometimes some programmers just use this integer function and math.floor function equivalently, which result in some very severe problems.
Your type is for math, so what your type
Oh, sorry, I just a typo here. This should be messed up floor. Thank you for that. Let me type it again. Okay, thank you for that. So this is a int function. So it can just keep the integer part of a number and just leave out the decimal part. And another function, another purpose of this int function is to transfer the string, the numbers in string types into integer. Okay, so if we see this int 3, but this 3 is a string, then we get 3 instead of 3 with quotation marks. So if we check this out, type 3, and what we'll get? We'll get string, right? However, if we incorporate this int function like this, and we will get class int, right? So that basically means the int function can convert certain strings to integers. Okay. However, it can only convert. The integer string. So what does that mean by the integer string? So check this out. If we have int 3.0, and we will get an error message. Since this is an invalid literal for int, so we cannot use this for argument. However, we can use this for the argument of int. Is that clear? Okay. So this is about the int function. And next, closely related, I want to introduce you the float function. The float function. So this float function can convert integers to float. So that's the first purpose. Float 3, and we get 3.0. So if we check the type of 3, and we get an integer. However, if we check the type of float 3, and we will get a float, okay? And additionally, this float function can convert the string types, decimal numbers, to float type. For example, we can have this 3.0 and get 0, and if we check the type of this, and we get float instead of strings, right? However, we cannot do this. We cannot do this, something like this, 4/2, and we will get 4, and we will get 4.2. Okay. However, if we add quotation marks here, and it will return an error message. Okay, so it can return this 2.0. However, if we add quotation mark, even we know this is 2.0, the float function cannot return this back. Okay, so that's some rules about this float function. And then I want to introduce you some another closely related function, which is a string function, str. So this string function basically converts all other objects into strings. As an example, we can see type 3, which is int. However, if we have type string 3, we will have this as a string, right? And it's similar for some decimal numbers. this is float, and if we type it here, and string 3.4, and we get a string. Okay, so that's this is for the string function. Okay, so we have introduced this int function and float function and this string function. So so the int function serves the purpose of transfer the other types numbers into integers, and the similar for this float and the string function. Okay. Okay. So now let's revisit our input function. So we have already know this input function, right? Now let's type this. Number equals input. So we use input like this, right? Please input. Please input a number. Okay. Please input number, and like 6, right? And we get 6 is the number, and we want to know the value of this input plus 3. So what should we do? We should do like a number plus 3. Oops! So there is a type error. It says it can only concatenate strings, not int to string. What does this mean? So this basically means the type of this number is actually string. However, 3 is an integer. So we cannot use these operators to combine those two ones, right? Right. So what should we do? If we want to know the value of number plus 3, we should do this. Like, so we can first check out the type of a number. See? So this is string. So how can we fix this problem? Int number plus 3. And this time it should work, right? And similar for the float. Okay? So actually, to quickly fix this problem, we can just directly put it into here. And in this way, this will not run into any problems. And we want to know number plus 3, alright? So we don't need to transfer the type again and again. So we can directly add an int in front of this input function. Okay? Is that clear? So by demonstrating this, I just want to remind you guys that the type of the input function is a string. So if you want to use the value of the input function, you need to first transfer the type of those of this input function, like numbers. Okay. Okay, and then I want to revisit this print function. Print. Okay, so the print function displays items on the screen. So, for example, if we print cereal, okay, and we get cereal, and we can also print some integers. For example, 1984, and it also works, right? And we can also this cereal plus HK, okay? And we can also do this, print a string and an integer, okay? Right? However, if we do this, print CPU plus this integer. So this is a mistake. So we get an error message. Since we cannot use these operators for an integer and a string, right? Right? Okay. So for the inches and the feet example, so we can directly use the print function and comma to finish this program. Like 41 inches equals comma 41 double slash 12, right? Feet and 41%, 12 inches. Okay? And we got 41 inches equals 3 feet and 5 inches. So similarly, we cannot do this. Right? We cannot just plus this here. So this is very obvious in these examples. So we cannot do this, right? So this is very obvious in this example. However, imagine if you use some input function to get this value. For example, you get some number of inches and get some number of feet. Sometimes you will just forget. So this is an integer instead of a string, and you cannot use this plus symbol operators to combine those two things. That is, one is string and the other is integer. You cannot do this. So please be very careful regarding this issue, okay? Okay, so this is a print function. Alright, so now I want to introduce you variables. So in mathematics problems, quantities are referred to by names, and names given to the values are called variables. And this is an example using speed and time to calculate distance. So first of all, it's like speed equals 50, and then it assigns the value of 40 to time. And then it assigns the value of speed times time to distance, and then in the end it prints the distance. Okay. So those three equations are assignment statements. It just assigns the value on the right side to the variables on the left hand side. Okay. So this 50 is the value assigned to the variable speed, and similarly this 40 is the value assigned to the time. And the distance, so the value of speed times time is the value that is assigned to distance. So that's the idea of variables and how to assign the variable with the determinate values. Okay. So there are very important rules. So variable names in Python, actually we begin, such names begin with letter or underscore. And the name of variables in Python can only consist of letters, numbers, and underscores. If you want include a person, a sign, that's not possible. Okay? And I recommend you guys using descriptive variable names. For example, if for the last example, so for the speed, so for simplicity, we can only use an S here. However, it is very intuitive. S can mean many things. Maybe a few weeks later, you will forget what this S stands for. So I suggest you guys using descriptive variable name. So for speed, you just write speed here. Okay? And some convention will begin with lowercase and use cap for additional word in the name. So what does this mean? So rate of change. So we begin with lowercase, which is rate, okay? And then we use cat for additional words. So oath and change are additional words. So for oath, we like O uppercase, and for change, we like the first letter C uppercase. Okay, so this is some convention for the name of our variables. And